The example x of t shown in figure 1.13a. The signal x of t plus 1 corresponds to an advanced shift to the left. This is x of t. So this one came here. This one happening will t equal to 0. This one happening here. But in this figure B, it is happening in -1. So advanced xt plus 1 corresponds to an advanced shift to left by 1 unit 0 to 1 unit along the t-axis as illustrated in figure 1.13b. Specifically, we note that the value of x of t at t equal to t0 occurs in x of t plus 1. Specifically, note that the value of x of t at t equal to t naught occurs in x plus t1. At t naught minus 1. X of t occur in t equal to t naught occurs in x plus t1 at t naught here at t naught minus 1. This is minus 1. For example, the value of x of t at t equal to 1, the value of x of t at t equal to 1 is found in x of t plus 1. The value of x of t the value of x of t the value of x of t at t equal to 1 at t equal to 1 is found in x of t plus 1. It is found in here t equal to t0, found in x of t plus 1 at t equal to 1 minus 1 equal to 0. That is 1, this one added, then 0. Yeah, happening. Also, since x of t is 0 for t is less than 0. When t is less than 0, here t is less than 0, what is happening? X of t is 0 for t is less than 0. So x of t is here 0. X of t is 0 full when t is less than 0. Here less than 0 only. That's why here in x of t, if t is less than 0, so full 0 only. Since x of t is 0 for t is x of t is 0, that is 0, t is less than 0. We have, well, t is that a time value t is less than 0. Here, full 0. T is less than 0. Start from here. Okay. We have x of t plus 1. We have x of t plus 1 0 for t is less than minus 1. We have x of t plus 1. We have x of t plus 1. We have x of t plus 1 0 for t is less than minus 1. That is here only. When t is less than minus 1, so x of t is 0 here. X of t is x of t plus 1 0 for t is less than minus 1. Similarly, since x of t is 0 for t is less than 2, where x of t is 0 for t is less than 2. X of t less than 2. Sorry. T is greater than 2. T is greater than 2. Sorry. Since x of t is 0, t is greater than 2. Yeah. Here. Full here 0. X of t here only 1. Here full 0. Here from here 0. Here slope only. Here slope. X of t plus 1 is 0 for t is greater than 1. X of t plus 1 is 0 for t is greater than 1. It means x of t plus 1 0 when t is greater than 1 here. Here 2. Okay. So here shifted. That is. So greater than 1 simple 0. Let us consider the signal x of minus t plus 1. Let us consider the signal x of minus t plus 1. Minus t plus 1 is the time reversed version of x of t plus 1. Yes. Time reversed means x there. T only minus. It means reversed. Plus 1 same here. So here reversed minus. Here in plus. So here reversed. Time reversed. Where x of x is the same. Plus t minus t. Plus 1 is there. So only time reversed. Time reversed means everything is reversed. It means this one reversed here. This one here. So this slope here. Then this one here. This one here. This one here. Minus 1 0 1. Minus 1 0. So Let us consider, so that is x of minus t plus 1 is the reversed version of x of t plus 1. Thus, x of minus t plus 1 may be obtained graphically by reflecting x of t plus 1 about the t-axis as shown in figure 1.13c. In C, what? Thus, x of minus t plus 1 may be obtained graphically by reflecting x plus t1, reflecting this only they reflect, and here this one only reflect here in C, reflecting about the t-axis as shown in figure, about the t-axis as shown in figure. Yeah. It means thus the x of minus t plus 1 may be obtained graphically may be obtained by graphical only by reflecting x plus t1 about the t-axis shown in figures 1.13c. The continuous time signal x of t used in example from 1.13 to 1.1 to 1.13 up to 3 problems 1.1, 1.2, 1.3. Okay. To illustrate the transformation of the independent variable. Transformation of the here transformation of the independent variable. Okay. Transformation of the independent variable. Then the time shifted signal x of t plus 1 b is the time shifted time advanced here. Okay, so time shifted b, time shifted x of t plus 1. C, the signal x of minus t plus 1 obtained by time shift and time reversal. C is the time shift and time reversal. Okay. C. D, the time scaled signal x of 3 by 2 t. This is the time scaled 2 by 3, 3 by 2. So this is happening. Sorry. This is here. This is here. So time 2 by 3, 4 by 3. This time scale here. And the signal x of 3 by 2t plus 1 obtained time shifting and scaling. Here also time shifting and scaling. Here from here d2. This one happening. No, here this one. Okay. This one. Yeah. So what is happening here? The signal x of 3t by 2, 3 by 2 t plus 1 obtained by time shifting scaling. Time shifting means this is the shifting. Scaling means this is also scaling, reduced, scale from compared to figure A. Figure A, figure B, figure C. Okay. So this is the signal x of 3 by 2 t plus 1 obtained time shifting and scaling. Okay. Figure 1.2. Example 1.2, given the signal x of t shown in figure 1.13a, the signal x of 3 by 2t corresponds to a linear compression of x of t by a factor of 2 by 3 as illustrated in figure 1.13d. It means the signal x of 3 by 2t corresponds to linear compression. This is the linear compression by a